Another Saturday morning project. Finally going to bite the bullet and do a CAN bus swap. So going with BigTreeTech's EBB36 version 1.1 and their U2C version 1.1 board. This is going to go in the 2.4. We're also going to be doing sensorless homing at the same time, so we're going to get rid of the drag chains on the X and Y, get rid of the Endstop switches, hopefully clean everything up, make a new harness for the umbilical. I'm also going to be replacing my existing clockwork too, which is a new fresh one. I started to do some modifications to the old one, tinkering with like the tool head PCB and stuff like that, and it's time just for a clean slate, especially with tap on the way. Hopefully we get those kits soon, get this up and running before that gets here. But yeah, should be, hopefully, I think install wise it's going to be pretty straightforward, and then it's just going to come down to the software side that might be a little tricky. But before we get started with the install, we are going to flash this outside of the printer. We're just going to do that on the bench. There are so many versions of how to install this and what to do and what printer, and it's just, oh, like you try and kind of have your ducks in a row going into it. And you know, so many of these people, they do great videos or great walkthroughs and they've got things explained well, but it's like from their point of view. And so sometimes it's something so simple they take for granted, and then sometimes it's something that's complex that's kind of taken for granted or just glossed over super quick. So hopefully we can take enough of that information, compile it, put it together, and have a pretty easy go at it. But yeah, so. Okay, so that guy, he didn't know what he was talking about because it wasn't easy, it wasn't quick, and it's not Saturday morning anymore. So we flashed the EBB and everything went great. Hooked up the UTC as it is, because you're not supposed to have to flash that out of the box, and the Pi wouldn't register it as a USB device, and it wasn't registered on the CAN network if we queried it. We tried reflashing the software on the Pi, tried, I mean, double, triple, quadruple checked every single little thing. We were always stuck there. So decided, hey, gonna reflash the UTC with the firmware from BigTreeTech's GitHub. Load it up into STM32, load the firmware, start the process, and it's showing that it's erasing, you know, all the different lines, and then it gets to where it's gonna start writing and it throws an error and just craps itself. So unhook it, hook it back up, try it again, and right off the bat, now it's in RDP mode. And STM is saying, hey, you can't, you know, you're not allowed to mess with this stuff, you can't do it. So I would sit there, and if I just clicked connect, 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 connect over and over and over again, I could almost like trick the software, because eventually it'd be like, hey, this is in RDP mode, do you want to deactivate that? And it'd be like, sure do, and it'd be like, cool, sure can't. And then it would, you know, kick the device off, and you'd have to restart the whole thing again. And then you'd connect, 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 and eventually it would just connect. And then you'd be like, ah, oh, here's my chance. I'd hurry up, and then it would not do it again. So I was pretty sure it was bricked at that point. And I kind of thought, hey, what do I have to lose? So we went down the avenue of trying some other stuff. So I found the DFU-Utilities tool for Linux systems that doesn't natively run on a Windows machine, but I also found Proton CLI installer that compiled with that, and then Zadig's USB driver flashing software got it working. So I'm not saying that this is the right process. I'm not saying that there's not an easier way. There's hopefully no one else that even goes down this hole, but I'm going to share it just in case. This is what got me from having to have a UTC paperweight. So anyways, back to the guy that doesn't know what he's talking about. So right off the bat, there's a couple things we need software-wise. We need STM32's Q programmer to actually flash our boards. We're going to need PuTTY and WinSCP to deal with our current setup and get some files off there. There is a way to plug this into the Raspberry Pi and flash it directly like that. For me, I'm going to prefer to do it on the desktop. Use WinSCP to pull that config off the Raspberry Pi and just plug this into my actual PC and flash it that way with the software. To each his own. You're also going to need a jumper to power the board while we're doing that. Just a little 2-pin connector. You probably took about 400 of these off of your Octopus from the drivers when you were setting it up. If not, maybe like 2 DuPont connectors or something like that. And then, alright, so we're going to go ahead and jump straight into putty here. Change directory to our Klipper folder. We're going to make our menu config. We're going to change this to the STM32 option, changing to the STM32G0B1 no bootloader loader. 8 megahertz is good there. We want CAN bus on PB0, PB1. CAN bus speed 1 million if you're going to use the ADXL. Perfect. Q to save, yes. Then we can make. Why was that so fast? Klipper out auto config. What if I delete it? I'm never gonna be done with this. It can't be done. Alright, jumping straight into putty. Go ahead, SSH in. Change directory to our Klipper, then we're going to make menu config. This should look familiar from when you set this up the first time. We want the STM32 option. Processor is the STM32G0B1 no bootloader. 8 megahertz is good. CAN bus on PB0, PB1, and we want 1 million CAN bus speeds if you're using the ADXL. Q to save, yes to confirm, and then make. Boop, boop, boop. Well, that's wrapping up. Open WinSCP. Now we'll back up just so you're going to go from home into your local, into Klipper, into out, and you can see right there creating hex file out/Klipper bin. That's what we want. And thanks to WinSC, we just drag it over here, click okie dokie, and there we go. We've got it. Alright, going to jump into STM32 Cube Programmer. And while that's starting up, we'll go ahead and grab our board. We are going to take the little jumper pin and put it on the 2 pins so that we can power it by USB. There's that little guy right there. Nice. Little note on USB cables. I wasted a ton of time fighting a USB Type-C to Type-C cable. I tried multiple different cables, multiple ports, couldn't get it to work. Eventually found out that you need a Type-A to Type-C USB cable. So your standard Type-A to Type-C. I don't know if that's the case for every cable. That's the case for the 3 or 4 cables I had here. Eventually got a different cable and it worked fine. Alright, so we're going to go ahead, open up our firmware file that we transferred over from WinSCP. Now you can see that there's no units in DPU mode, so we're going to go ahead and put our board into a flashable state. There's the 2 buttons, one's up on the board's upside down, so it's on the bottom, but it's by the main connector. You're going to press and hold that one, and while you're holding it, you're going to press and release the button right next to the LED. So press and hold that one, press and release that one, and then release the first one again. And there's no change on the board to signify that. You just go back to STM and you can see that now it recognizes the USB drive. So then you can just go ahead and click download, which is the same thing as flash, or you know, you're downloading it to the board, not downloading it off the board. So not gonna make you suffer through this whole process of getting everything set up. That took longer than I thought, as they usually do. This is at 10,000% and it still seems like it's taking too long. Mostly just had to do some wire extensions on the tool head, the two fans, and the LEDs, as well as the thermistor and hot end. God, I hate that fiberglass jacket that seems like all the hot end wiring have. It's just, it's not that bad stripping it back, but it just feels like it frays. And even if you put a little heat shrink on it, like I did the first time, then when it's coming out the bottom of the board, it kind of makes the wire too stiff to bend to not hit the extrusions. But we ended up getting it figured out. It was just a bit of a rinse and repeat. Anyways, there's some crimping and a little soldering and yeah, oh yeah, look at that. That's great. Oh. Yep, nice, nice. Ooh, oh, I don't know what happened here, but got a little freezy. I promise you're not missing anything. Cutting some wires, crimping something. Oh, oh. Z chain going back on. Nice. Look at that. To the bottom. Okay. Ooh, look at that rat's nest. We're pulling everything out, so there's a lot of wires coming out here. Definitely spend some time doing this. A little bit of effort's going to save you a lot of trouble later. Alright, so we're going to do this at normal speed real quick. So I have the board hooked up through the harness, and there are these 4 terminals right there. It's actually 6, the CAN high and low share 2 terminals. But you can put a meter on one of those actual solder joints and then put your other end of your multimeter on the other end of your harness, set your meter to continuity mode, and you can triple, double, 100% be certain which wire you're dealing with. So you've got the EBB plugged into your wire harness, so you touch, you know, 24 volt positive on the EBB, you find out which wire it is, it goes straight in the U2C, and there's no mixing it up. And you can use the screw terminals there. You don't have to use the white connector. It's all the same. They all go to the same space on the board. And right there, I forgot, but I needed to put power from the 24 volt power supply. So I cut off the existing ferrules, put on the 2 new ones. Everything was good there. Here we go. This is kind of what I was talking about with those 2 hot end wires where they come out of the bottom of that EBB board. Putting heat shrink on it to keep it clean made it so that the wire wouldn't bend right, but I just shortened the heat shrink and it worked fine. So now we're going to go ahead, unplug the USB board, plug in our Type-C cable from our computer, and we're going to press and hold that white button before we plug it in, and then release the button after we plug it in. Oh, look at that, it connected. So we thought. We go ahead, get our firmware file, and download, and it just stuck here forever. Like, I gave it plenty of time, and nothing was happening. So ended up killing the process, I think after like another hour and a half, and it was still at 0%. So unplugged it, plugged it back in, put it back into DFU mode, figured let's give it another shot. It finds the board, it knows it's there. Let me connect to it now. Come on, let me connect to it. Oh, it let me connect to it. How cool. Erasing, 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 erasing. It's working. It's actually working. Eat shit. And try again. Reconnect. What? Read protection mode? Yeah. So this was like a day and a half adventure. Different computers, different options, different versions of STM32, trying to flash things, erase things. It was just stuck in circles. Couldn't ever get past this. Alright, unplug the board, plug the board back into the Pi, go ahead, fire up PuTTY here, and we're just doing LS USB, which is going to list all of our attached USB devices, and lo and behold, it's not showing. So the board's powered on, everything should be good, but the Pi is not even recognizing the board, no less the CAN network. So we're just going to go ahead and kill that. And now we're going to open up our slew of tools that we're going to use to save this thing. So the first one is the Particle CLI installer. We'll go ahead and get that going. Then we can jump over to the Zadig USB driver tool, get that down, and then the DFU utilities, and we're going to get the most recent Windows zip file that is there. It's only, I think it's back in version 9, but that's going to work. At least it did for me. And a boo-boo. Well, that's finishing up still. Now we're going to do the DFU utility, and you're going to see it like flash a window and close. That's it. That's all you need. Now we're going to put our board back into DFU mode and reconnect it to our computer, not the Pi. Open up Zadig, go to Options, see all the devices, click on the STM32 bootloader, and mine is still flashed from the first time I did this. I couldn't get this to go back to its original state. So you'll just click that button down there. Well, it'll just say, you know, flash firmware. It takes a while. Let it do its thing. Then you'll come down to your command prompt, and you're going to type this in. I'll put this in the description just so you can copy and paste it. You're going to have to update it to your correct file and your file address, but you can copy the first part. And then when you get here to the file extension, make sure you're using quotes, especially if you have a space in your directory. Like my directory has my name on one of them, and so there's a space between the first and last name. That'll ruin it if you don't have quotes. So another thing, when I did this the first time, it did 2 files that it downloaded and installed and flashed. And that might have been fixing the bootloader and then the firmware. I don't know, not a rocket scientist. I don't know how it works. I just know it did. So when I was redoing it this time, after trying to recreate everything, it just did 1. Also, the first time I did it, it took probably 45 minutes. So just let it do its thing. I know, you know, the first time when I did STM32, I let it run for an hour and a half and nothing happened. I did the same thing with the DFU utility, and it actually worked. It slowly made progress, and it did it in like chunks. It would go 0 to 12%, 12 to 38%. So if you're not seeing 1, 2, 3% increments, don't worry about it. And then knock your camera over and drag everything off your desk with the cords. Yeah. Smooth. Alright. plug your U2C board back into the Raspberry Pi, turn it on, go to PuTTY, fire it up. And look at that, open Momo. We can see it. Success. All right, and then at this point I did go back and I completely wiped and started with a fresh install on the Pi. So real quick here, I am going to jump in and I'm going to set a static IP for whatever. I have a Netgear router, and if I assign an IP on my router, it freaking hates it. It can't figure it out. Everything gets out of whack. I don't know what's going on with it. So I have the DCHP set to only assign from 20 to like 180, and then I can come in here and assign static things at like .196, which is what I'm going to do for this. So most things in my house aren't set to static, but the Pis usually are, and this is just a quick way around it. And then when you're, I don't know, you can set up PuTTY and WinSCP to have a consistent login. You can do the same thing if you just use the name instead of the IP, but yeah. Anyways, that's not what this is about. Should have fast forwarded through this, but I'm just gonna have to sit here and watch me type this out slowly. Hunt and peck, 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 peck. Ugh. Type faster. Control X, Y to save, enter to confirm, do a little sudo reboot. Open her back up with the new IP. Bam! All right, now we're going to go back to the EBB instructions. We're going to go down here to the bottom, and we're going to set this network interface up for CAN 0. So copy and paste that sudo nano part in. And then you're going to copy and paste these 4 lines in, and you're going to make sure to change that bit rate to whatever you did on the original EBB board, sorry. So I did 1 million, and we're going to stick with that. And confirm, enter, save, reboot again. I'm going to get real good at rebooting. And I've kind of cover that up with the other camera, but I was just copying the next bit of info. And this is another one of those things that once I got this working the first time, it didn't disassociate 100%. So when I run this query tool, I'm going to get 0 boards found, which is actually a good thing if your setup's already up and running. If you read the rest of this instruction manual page, it'll say it's only going to show you boards that are like unassociated with your network. So once it's associated, you're gonna see 0. That's good. What I was getting before was like hashtag go F yourself, error, error, error. And anyways, all right. But you would have copied the USB ID. That's important. You would need that. Now we're gonna go ahead, and I'm actually gonna bring in my backed up printer config. I'm not going to start from scratch with BigTreeTech because I don't hate myself that much. I'm going to go ahead and put in our MCU section. We're going to comment out the serial line and uncomment out the CAN bus, and you're going to put your UUID number right there. Yep, that looks. Not that UUID number, your own one. All right. Then we're going to go over to BigTreeTech's example config. We're going to go down to our extruder section, and this is when we're going to start transferring over and replacing our old pins with our new EBB CAN board pins. So we're just going to go through and do the step pin, direction pin, enable pin. I'm not changing the rest of everything, just the pins. And right below that you have your UART pin, which you don't want to forget about because you actually have to, they put the max file in between, or the max 13285, whatever it is, in between. Then we got to make sure to do our fans. Don't forget those. On the board, they're not really labeled which fan's which, so you're going to want to make sure before you go printing that your hot end fan and your part cooling fan are correct. You don't want to make sure, you know, your part cooling fan's on 100% of the time and your hot end fan's sitting at 30% of the time sometimes, so make sure that's right. I'm going to go ahead and get rid of all of those from my previous life. We're not doing Auto Z or any of that anymore. Getting rid of the old ADXL information, we're going to put in the new stuff, and we need to make sure that we keep that resonance tester section. I got rid of that the first time and chased my tail, so make sure that stays. Alright, everything looks good. We can save, close out of that. Now we're going to set up our sensorless. We made sure to remove all of our physical end stops. If you have an old end stop still plugged into your Octopus board, it's not going to work. And we put the 2 diog pins in the correct spots for the X and Y stepper motor on the Octopus board. Alright, it looks like we're going to go ahead and clean up those empty spaces. It felt important at the time. We're changing the homing speed to 40 based on some information I found on the Discord. The actual docs say 20. I was getting better results with 40. And I guess that's kind of a good time just to say the sensorless homing is definitely not perfect. Trying to find the right sensitivity, for me, it's still a work in progress, and it's something that needs to be monitored. I do not trust it enough to be like, oh, I'm going to home and walk away. I am at least making sure the homing process went right. So, forewarning. We're going to go ahead and copy in that new end stop pin, and I put it before, I'm not getting rid of my old pin number there. I put it before the pin, space, comment, so that I have the old pin number commented out after the end stop pin that we're adding. Because then under the stepper section, you have to enter the diag pin that you're using. You're going to put the little caret there, and then you're going to put the old pin that you just commented out. So that one, you can see PG6. This one will be PG9. Muy importante. This is the Octopus Pro instructions. We're not that cool. So now we can save, restart, and we'll see what Klipper wants to throw a fit about here. Nope. Macaroni file. That's just a thing full of macros, not pasta. And we're also going to go ahead and enable this force move section real quick as well. We're going to need that here in a minute. Ooh, still needs the macaroni thing. You missed that. You forgot that, dude. Figure it out. Go to my backup file here. Should have fast forwarded through this. System said, ooh, all your Klicky files. So close. What are you doing? Oh, just upload them. What? Oh, there you go. Warmer, warmer. On fire. Nice. And you're going to want to go ahead and set the Klicky probe pin as well. That's an important step. Don't forget that. Go ahead and show you back up early in the manual. Oh, don't tell me I cut. Ah, nice. So I used PB8 and ground on this bottom section. Ground and signal. Do not use power on your Klicky probe. Bad. Bad. Save, restart. Ooh, yeah, I have the LED effect thing in. So I did time warp through this, so it saved you some trouble there. This is just for little LED effects, and then my printer power configuration file. I've got the 24-volt power supply on a different relay. That's what that's for. But it looks like now we're up and running, and now you can see that we have our EBB module shown right here. So it is officially set up, and the CAN system is working. All right, so I'm going to go into Klicky variables, and I'm going to turn off my toolhead parking. I don't want it trying to throw the toolhead all over the place right now. And this is where we're going to set a, we're going to use the set kinematic position in order to essentially trick the printer into thinking it knows exactly where it's at. And forewarning, foreshadow, whatever you want to call it, be careful doing this. You're overriding a lot of the built-in safety features where it's super easy to crash if you're not paying attention. So I know I'm roughly X150, Y150, and Z150, and I'm doing this so that I can, I need to bring the printer down because, you know, every time you reinitialize and you go to home, it's going to try and move the Z up a little bit to a safe area, and you do that 3 or 4 times, and all of a sudden you're halfway through your print volume. So I'm going to use that a couple of times. I'm comfortable using it. If you're not, don't do it. Either way, pay attention. All right, so now we're going to go ahead and set our Z sensor sensitivity. We're going to walk a little, oh, yeah, not 20, 200. And it moves, that's good, goes right back, so we'll take another step down. Same thing, another step down. Mine seems to be, I have to get to the lower end of the sensitivity based on what other people have posted, so I don't know what that means, if anything. All right, so 100, I'm finally moving. I'm gonna stop it with my hand just to make sure it stops, and if it doesn't, that gives me a split second to get to the emergency stop button. Don't forget there's one on the actual display if you're not using a big display. So now I'm gonna try and kind of fine tune it a little bit more. Nice. So I'm gonna take that value. Actually, I'm going to double check it. All right, now I'm going to take that value, go back to our printer config, and on the X stepper motor, I'm going to change that from 255 to 90. I'm going to save and close, not save and restart. Still need to do the Y. Try and give you a better view over here. So same thing, we're just going to change that code to have a Y in it. Go back to 200. Y home. Ooh, 1600. How's that going to work out for you? Don't be like me. Take your time. Methodically type everything out. And you can see it's kind of walking backwards because it thinks it's up against the end stop, and so it's set to go up against the end stop and then back off 10 millimeters. So it kind of just continuously thinks it's there. Anyways, we found the threshold, stopped it by hand, try it again, and see that that's kind of one of those where the sensitivity's right on the line there. Sometimes it works, sometimes it doesn't. So drop it a little bit more, try it again, and we get a good stop. Manually put it back in the middle of the bed. Home the X again. I do this 2 or 3 times on camera. Over the whole course of this endeavor, I did it, I don't even know how many times. But like I said, it's definitely something you want to spend some time dialing in, getting comfortable with, not just a one and done, forget it. So go back into printer config. We're going to update that Y value for the sensitivity. Go back to the Voron docs, and we're going to copy this macro, create a new file. We're going to call it sensorless.cfg, and then we're going to struggle to paste that macro in there. We're going to think we didn't copy it, and we're going to try copying again. We're going to paste it again and realize that's not working, and then we're going to go back and we're going to retry copying it for the 3rd time. Oh wait, you have to click and okay, that makes sense. Save and close, go into printer config. Now we need to add a include line. Include sensorless. Save and restart. And now we're going to home the X and Y. I'm not sure why it lists out all the run currents now that I haven't figured it out. It doesn't really bother me, but so we're going to reset our kinematic position. Again, this is just getting it to think that the Z axis has been homed. We haven't set up our Z Endstop, the physical one, and we haven't configured the virtual one. So we can't actually home the Z right now, so that's why I'm doing this, to kind of circumvent that so we get some more flexibility with what we can move. Before we do any of that, I want to reset our bed position. So we need to get the nozzle over to 0, 0. And I'm not going to just blast straight to 0, 0. I'm going to set it to like 50, 50 and kind of work my way down just to avoid any crashes. And another point of being able to do, if I do the set kinematic position, when you can move the Z like this, you get a better idea of where the nozzle is. I'm really bad, like if the nozzle's 100 millimeters of the bed, I'll be like, oh yeah, that's right over the end stop, and as it moves down, it's like an inch off to the side. So the closer I can get the nozzle to the bed, the more accurate I am with being able to tell. And here I am, we're 20 millimeters out on either side, and I'm just verifying that I still have enough room to move that in. If it was, you know, already up against the edge, and you wouldn't want to try moving at 20 millimeters, you're going to crash it. And so now I'm just tiny little steps. It takes a second, but it's worth saving some broken parts. And 0. Alright, so we got our X to 0. Now we're going to do the same thing with our Y. Alright, so now we're at X0, Y0. and my nozzle is still over the bed, which is a good thing. That way both of our max positions and end stop positions move, and we don't have to do any math. So I'm just dropping the Z here, get it pretty close. Sorry for the motion sickness. Trying to just kind of show that it's still over, but you can see that on the y-axis there's a pretty good gap in front of it, and on the x there is a gap to the left. So I've just got a little metal ruler there, and I'm just roughly trying to get the best measurement I can of how much it needs to go either way. And we're doing this because when we got rid of those end stops, the tool head now moves in the x and y directions more before it physically stops. So if you just leave everything as is, it still thinks it's at the same position it was originally when it stopped with the physical end stops. So everything's just getting shifted over a couple millimeters in each direction. But so we've got our what we need to change. We go back into config here, and we're going to go position end stop for x. I'm going to add 5 millimeters to both the end stop position and the max position. And save and reset. And hypothetically, or theoretically, you could have a bigger position than the end stop. Like if your end stop was at 200, you could have 300, but that's not how this is. So we want to make sure that your max position isn't bigger than your end stop position. So got it restarted, gonna go ahead and home it again. And it worked like a charm. Just to kind of repeat, I'm gonna have to set that position. Now we know, you can see right there, we're at 295 and 300, so it's no longer a guess on the X and Y position. And you can actually just put in your Z. So it's changing that just again, just so we can move. Go 50-50, 5-5. Don't mind that crater in the PEI sheet. So again, just triple checking that the nozzle's in a good spot. And then we're going to set it to the max build plate and see where that ends up on the other side. Bump the Z up a couple millimeters first, send it back over there, and with any luck it'll end up right on the other corner, which it does. Alright, and I'm going to go ahead and restore. I did back up my UI settings and everything before, so I'm going to restore that real quick. And if you go to control, there is a little, you can add the option to have the X and Y homing instead of home all. I've been using that throughout this, but I didn't show enabling it the first time. So now we need to get the Klicky location set up. We're going to go and find out. That was our previous location. So we're going to keep that in mind. And after it's homed here, we're going to stop and think about something. Oh, there we go. Someone should tell him that he doesn't need to do the X and Y. You can just do the Z. You just did that a minute ago. So we're going to go over to the X39, which is what we were previously set up for with the Klippy probe. And we got Y at 270 just so it's backed off just a little bit. But you're going to look right down that nozzle and make sure that nozzle is dead center in the Klicky probe. And I'm not right now, so I'm going to shift over about 2 millimeters. And then you can sit here and just slowly walk the tool head back with the Y incrementing it one at a time. Keep going, keep going. It's getting pretty close. And then we pull back out, and you can see it's attached. And now we want to put it back in, and it should just smoothly go right back in. 305 was a little bit too far, so 304 is what we're thinking. Go back out, try again. That looks pretty good, 41 and 304. So then we'll take our X and we'll add about 50 to it and make sure that we get a clean disconnect. So then we can go back into our Klicky variables, change that to 41 and that to 304. Save and reset. Do another XY home. All right. Bring the Z back down just a smidge, just so it's easy to work. Now we're going to do the attach probe macro. Make sure everything there works nice and smooth. And I'm just going to go ahead and throw the tool head back into the middle of the bed and then dock it just to act like it's a real scenario. Perfect. Now we're going to get ready for the virtual Endstop. We're going to use the Klicky probe to do the Endstop now. And again, this is another thing I forget who it was on the Discord that essentially said with doing the sensorless homing, you get another level of failsafe using the Klicky as the Endstop. If your sensitivity is off just a smidge, or for whatever reason it stops prematurely of the actual end of its travel, instead of just missing the Z Endstop, you know, sex bolt or the physical Endstop and diving into the build plate, if it misses picking up the Klicky probe, it's just going to throw an error and stop. So you might still crash over on the Klicky probe side, but you're not going to crash into the bed, and I think that's generally a preferred thing. I'm also getting rid of the Auto Z because I don't change build plates, I don't change nozzles, as much of a novel, cool idea as it is. And don't get me wrong, great, it worked fantastic. It was extremely good at what it was. I'm just going to go back to setting an old school, you know, a consistent Z offset, and I can dial it in once a month or once every, however often I need. I don't change things that often. So anyways, hopefully you were paying attention there. We're updating the config file with some of the stuff for the Z Endstop. Much like we did the X and Y, we're going to set that one to a virtual, and we're going to update some stuff in the printer config and the Klicky file as well. Now we're going to home all. finally, no more bed kinematics. In retrospect, I probably should have triggered that with my finger the first time, just in case, but it worked out. So, super. Alright. So I'm going to go back into Klicky variables here, and I'm going to turn the toolhead parking back on. And mine's set to 150 because I want it parked in the middle of my bed, and it's at 300, so that makes sense. And then you can also, if you want it parked a little higher or lower, you can adjust that. Better safe than sorry. Restart again. Home all again. Now that I'm going back and doing the voiceover for all this, I should have sped up through some of it. Mazel tov. All right, so now we're going to go ahead and do a probe calibrate. And since that recent update, now you get the nice little on-screen, you don't have to do the Z test thing anymore. So you can still see it's slowly moving out of the way right there, and it's raising a little bit. And if you read the console, it's going to ask you to manually remove the probe. Make sure to put that back in the holder, otherwise you're going to forget it, and then you're going to go to home it, and it's not going to find it. It's going to throw an error. Did that like 6 times. So then you're just going to sit here and old school paper. Come on. Go, 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 go. Start clicking slowly. Slow down. Whoop. Nothing. No. Oh yeah. Too much. Just a smidge. Oh, better. Anyways, this is more just, this isn't the final one. Obviously the panels are off. We're not, it's not hot. Nothing's heated. So. This will definitely be redone. Except, now if you go save config, it's going to tell you to go get effed because it's going to say there's a bunch of problems. And you're going to go ahead and update your probe offset with the same value that it just gave you. Save and restart, and you're done. Congratulations. The only thing that I didn't record that you will want to do is put a little piece of filament in the extruder, and you can heat up your hot end, manually extrude something and see if it pushes or pulls it. You might need to go back into your config and do a little exclamation point on the direction pin if you have a problem there. I'm going to go ahead and uncomment out force move so that nothing funky happens with that accidentally. And yeah. One more time just to make sure everything works, but we are good to go. It's like 2 cameras watching each other. Anyways, thanks for watching.